everybody. Hope you're doing great. We're on page 94. 94. We're going to do some key concepts today for you on 2-2. Okay? So, guys, we're solving variables on both sides of our equation now. All right, let's take a gander at everything we got here. All right, let's zoom in a little bit for you. Bam. All right. How do you use inverse operations to solve equations with variables on both sides, right? So we've got variables. So guys, in other words, we'll have something that looks like this: 1/4 x plus 2 equals 1/2 x minus 4, right? This is what we're doing here. So how do you use inverse operations to solve that? Well, it's pretty easy, right? Step number 1, move all of your variable terms to one side. Okay? So all the variable terms get moved to one side. Step number 2, got to do with the constant terms, right? So we can move constant terms again. They have to move away from the variable, so they have to go to the other side. Okay, that's how we use inverse operations to solve these equations, right? Really, to solve any equation, guys. Collect your variable terms on one side, move your constant terms to the other. Okay, guys, good? Of course you are. Moving on. Why are inverse operations and properties of equalities important when solving equations? So this is the kind of stuff that we just do without really thinking about it, right? So inverse operations, guys. Inverse operations, right? So in other words, guys, when we think addition, right, that pairs up with subtraction. When we're thinking about division, that pairs up with multiplication, right? Those are inverse operations, right? They basically let us undo whatever operation is being done so that we can move, I'll just put a term to the other side. Okay? So guys, this lets us move a constant term or a variable term from one side of our equation over to the other side. Okay? So if we see subtraction, we have to do the opposite. We have to add it, right? Because basically we want it to undo itself, cancel itself, go away, and then we can do the same thing to the other side of the equation. Okay? By doing that, guys, we don't really change the meaning of the equation, right? That's key. Okay? One more thinking question here. Oh, I love these ones. Cynthia earns this much in commissions and is paid this much per hour. Okay? Javier earns this much in commissions and is paid this much per hour. What will you find if you solve for x in the equation, right? So they've already made the equation for us, guys. When we solve for x, though, what are we finding? What are we finding? So 1025 has an x, 1250 has an x. Those, right, those are hourly rates that they're getting paid, right? Here's how much money Cynthia makes. Remember, she makes money two different ways. She gets this hourly rate. She also gets this commission. We add those two amounts together. That's how much she gets. Same structure happens for Javier. He has that hourly rate. He has that commission. We add those together. Well, x is representing, guys, how many hours they work, right? So if we solve for x, x is, I'll just say, the number of hours that they work. And in this case, more specific, it's the number of hours they work to make the amount of money equal to each other, right? So x is the number of hours they work to, I'll just say, earn the same amount. Okay? So again, we would solve that. Do you want to solve that equation for x? Nah, it's too early. Right? Don't worry about it. Let's get into some more stuff. Here we go, guys. 6 and 7. Both of these are straightforward, right? I'm just going to show you the answer. Again, I'll talk you through it. I would move negative 2/5 over here with 2/3. Move 1/3 over here with 3. We're going to do all that. Good things are going to work out, guys. We're going to get x is equal to 2.5, or any other form of that number, right? Whether that's 5/2 as a decimal, there you go. I don't care. Any equivalent form, good to go. But that's what you should get when you solve that. Okay. Same thing down here on 7, right? Variables on both sides, constant terms on both sides. Which one should we move? Make a good math choice. Move negative 2.6b over here to the right. Move that 17, a little bit of addition, back over here with 4. Okay. We do all that, we actually get a good number here. B is equal to 6. Okay? Again, we've solved a whole bunch of these equations, so the process, guys, is not any different. Doesn't matter. Decimals, fractions, integers, whatever kind of numbers they give me, we should be good. All right. Okay, guys. Hey, we had a weird technical difficulty there. We're all back. It's all good. Hey, we're on number 5 here. So we're talking about Selma. We are talking about Trudy, right? And they're packing different boxes and everything. So once again, guys, I need you to go ahead and make an equation, right, that represents Selma. Make another one that represents Trudy, how they're packing boxes, right? If you do all this right, our answer for this one, right, we're trying to figure out how many minutes do each of them need to work in order to pack the same number of boxes. Well, it's 105 minutes, right? 105 minutes. Okay? Awesome. Good job there, guys. You did fantastic. Moving on to the last one here. All right, we should probably do all of this one. Maria and Liam work in a banquet hall. Maria earns 20% commission on her food sales. So remember, commission is, hey, we earn this much. We take 20% of that number. That's how much we make. Liam earns a weekly salary of this, $625, plus 10% of his food sales. What amount of food sales will result in the two of them earning the same amount of money? So once again, guys, it's that same structure that says, hey, Maria has to equal Liam. Okay? That's all it is. All right, so Maria, she doesn't get paid a salary. She just gets 20% of what she is of these food sales. So Maria is going to be something like this, guys. 0.20F, right? Again, you tell me how much she had in food sales. We multiply that by this 0.20. That's how much money she makes, right? Our friend Liam, a little bit different. He only gets 10% of the food sales, right? So that should keep that same structure. However, he also gets, right, this $625, right, on top of it, okay? All right, hopefully you've got a calculating device like I do. We got to solve this equation here. So move your variable terms together. Not a great choice to move 0.2 over here, because then we got nobody over here. So we're going to move 0.10 over here, so we're going to subtract that from both sides. I think we can all handle this in our head. 0.10F, subtract. It's just going to give me 0.10. And that equals, heck, I don't even need this anymore. I know what the answer is going to be. All right, here we go. Divide by your coefficient. So we're going to divide by 0.10. So divide. Okay. Running out of room. F is going to equal, well, when we're dividing by a number smaller than 1, guys, and happens to be 10, we're really just going to add a 0 onto the end of this and say, shabam, $6,250. That's big brain right there. So anyway, so guys, this was our key concepts. This is on page 94. We should be ready for some other activities at this point in time. So let's take a look at the agenda, see what that is, and we'll keep solving equations.